I would like to invite Mr. Nitin Vaidya. Nitin Vaidya has over 40 years of experience in the surface coating industry. He is currently working as a divisional head at Aquarius Engineers Private Limited, Pune. His main focus is on providing environment-friendly equipment used in paint shops and surface treatment plants. Some of the key systems he works with include automatic paint sludge removal systems, solvent recovery units, grating and jig cleaning systems, centrifuge separators for photophosphate, for phosphate sludge and oil separators. He also deals with related chemicals and additives that improve efficiency and reduce pollution. He has worked closely with international companies like Hydro Italia and IRAC SRL from Italy and STA GmbH from Germany to bring their advanced technologies to India. So Mr. Vidya is also certified in quality system, customer relations, and financial management, making him well versed in both technical and business aspects of the industry. So I would like to invite Mr. Nitin Vaidya, sir.
Yes. Hello, very good morning. My name is Nitin Vaidya. I am from Aquarius Engineers. We just had a very interesting and very informative session from Mr. Manjrekar, my colleague, my senior colleague, I should say. He spoke about different types of paints and the different types of coatings, the technologies involved. I am here to talk about the other side of the story. So you'll be wondering what is the other side of the story. The other side of the story is that the individual paints, they have their own names like PU, epoxy, ABS, this, that. They have their own identity with giving the beautiful colors, beautiful gloss, and they have their own properties also. But once they are applied, there is a lot of overspray, more or less, and this overspray together is termed finally as paint sludge. They lose all their identity. They lose the PU identity, they lose the epoxy identity, and it comes in a general form of paint sludge. This is a harsh reality of the paint shop, the liquid paint shop, right? The liquid paints. So I'm here to talk about the paint sludge cleaning, the paint sludge removal. There are various sludges happening in the paint shops. I'll be talking about the paint sludge removal processes involved in the paint shops. I will just first mention about my company from which I come, what it is about. This is the Aquarius Group. We are basically into two areas. We manufacture our own construction equipment as well as we have an environment division. I come from the environment division. So in the environment division, we have a lot of environmental products for which we have manufacturing collaborations with Italian and German companies. We also have the construction equipment of various sorts. So these are the group products. So I'll quickly proceed to the collaborations for the environmental. The first collaboration is Hydro Italia. This is basically for the automatic paint sludge removal systems and the various other aspects of paint sludge removal. And of course, the important chemicals required for the treatment of the paint, overspray paint. The second is with IRAC. This is for the solvent recovery plants. This is the dirty solvent which is normally collected during the cleaning of the guns. So very important requirement of paint shop is to clean and recover the solvents and recycle the solvents so they can be reused. And the third one is STA GmbH, for which again we have a manufacturing collaboration for centrifuges, different type of centrifuges. These centrifuges are basically for solid liquid separation. They are ideal for applications like phosphate sludge removal, degrease sludge removal, and many other applications outside the paint shop also. So this in short was a small introduction about my company and the products. Now let's begin with the paint sludge aspects. Now these are all the ideal conditions of or objectives of sludge management. As you can see here, a number of them, the major at least have been highlighted over here. There are so many others also, But these are the objectives which each and every paint shop should have as far as the sludge which is coming out of the paint shop. So the first would be to produce as less as possible. That is the main objective, of course, that if the sludge is less, then hardly any further problems would be coming. The equipment required would be much less, so on and so forth. So each and every point over here mentioned gives us a very clear understanding as to how to handle the sludge, how not to produce this sludge, how when you do at least, I mean it's a harsh reality that sludge will be forming. So what are the things that would be required or are supposed to be taken as a goal to remove this sludge from the paint shop and have a trouble-free operation of the paint shop. So we'll move on to the equipment and the procedures followed to take care of these objectives in the paint shop. Now we go to the sludge generation in the paint shop. I have just generalized a slide where we just identify where is the sludge coming from. If you are clear where the sludge is coming from, then it becomes very easy to attack it and go ahead. So first and foremost, obviously in the paint booths, this is the biggest area where the paint sludge is produced. Because as you can see, in the liquid painting operation, you have the major overspray generated in the paint booth itself. The second is, of course, I mentioned earlier, the dirty solvents. These are formed when you have the paint guns being cleaned. So you have a lot of dirty solvents collected, and these create a lot of unsafe environment as well as a problem for the disposal. So that becomes the second point of the dirt or the sludge being generated. The third, of course, is gratings or skids. Now, when you go inside a paint booth, you have the painter standing on the gratings, and you often will observe that there is a lot of sludge being accumulated on the gratings itself. Also the components, the bigger ones, like you go to the auto industry, you'll see the skids on which the component is kept. It will be totally covered with paint. Now this is another area where you will find that there's a lot of sludge being created on it, and it needs to be tackled, it needs to be handled properly. Otherwise, we have heard from Mr. Manjrekar about the electrostatic guns and how the painter has to be grounded earth properly so that the paint doesn't come on him. Now, if the gratings are not cleaned properly or the skids are not properly, you'll have the paint coming on the painter. He will have a lot of addition of the static charge onto him. It becomes very unsafe. The final one in the paint booths are the hooks and the jigs. As you know, when the painter paints, the component is onto hooks and jigs, different kinds. And you'll have a lot of paint going onto these jigs, onto these hooks. And again, especially for the electrostatic painting, you'll have to have an earth component for achieving the highest transfer efficiency. So these jigs, these hooks have to be cleaned properly, thoroughly, to ensure the high transfer efficiency of the paint and save the paint, of course. Now we go from the paint booth to the pre-treatment area. In the pre-treatment area, the major sludge is produced in the phosphate sludge, which is part and process of the phosphate process itself. So you'll have a lot of sludge which is being generated in the phosphate sludge, in the phosphate tank, sorry. The second one is from the degreasing tank. You'll have in the degreasing tank a lot of sludge being created. This has two parts to it. If the component is cleaned earlier with some blasting and all that, you will have a lot of metal burr coming into the degrease, because that's the starting point of the treatment process. You'll have this metal burr inside. You'll also have the grease and oil and all these things getting added to the degrease when it cleans the components. So that is another area where you'll have the sludge coming out in the paint shops. I've just made this slide for you to understand the industry standards. We are not talking of robotic painting, we are not talking of highly automated paint shops, we are talking of general paint shops, where you see the industry average is about 50% waste. So if you paint about 100 liters every day, 50% of the paint is supposed to get wasted, or it is rather wasted through the overspray, through the thinners being, evaporated and all those things. So this is the industry's average. It is not pertaining to something where, where the automation is there or robotic systems are there. But the other industry, if you see the other components, this is the average. Now there are various aspects or areas in methods in which you can reduce this. I've listed some component type, applicator, jigging pattern, paint type, painting skills. So all these are individual areas where you can try to, bring down the loss of the paint by seeing how best it can be jigged, by seeing how best the skills can be developed. So this is a different subject by itself as to how to reduce the oversprays, how to utilize maximum amount of paint. So we will not go into that. I will now cover what happens when the overspray is there, because that's, as I said, as a harsh reality of the industry where so much of paint is being wasted. Okay, the first and foremost area of attack, I would say, or the procedure for treating the overspray is the chemical treatment of the overspray, of the sludge. Now this is something which is very, very important. People normally concentrate on the equipment and the remaining accessories and all that of the paint booth or the removal systems. But first and foremost area where you need to concentrate are the proper chemicals. The proper chemical reaction is there. So that the objective is to make the paint non-sticky, to make it into a particle form so that it doesn't stick onto your booths, it flows out of the booths towards the sludge pit or whatever the design of your paint shop is. So this requires the use of various chemicals like coagulants, like flocculants, pH adjusters, biocide, depending on the type of paints that you use. So the chemical can be decided based on what type of paints you're using. So these basic type of chemicals are there. The other two items which I've listed down are equally important. Equally important because to have a chemical reaction, a proper chemical reaction, you need to have a thorough mixing of these chemicals with the oversprayed paint. Many a time I have seen in paint shops that they're using the best type of chemicals, but they're not getting the effects as much as required. It's a total failure on the pre-treatment of chemicals. Not because the chemicals are bad, because there is hardly any mixing of the oversprayed paint, water and the chemicals. So it's just like the chemicals are sitting there, the paint is sitting there, but they're not reacting with each other properly to give that final effect of a non-sticky particle form paint. So having a very efficient mixing system is very important. At the same time, I have seen in many paint shops that the chemical is being just dumped into the paint booth or the sludge pit at one time. It is not required to be done in that way. The best way to do it is to have the chemical dosing in a very continuous way. Throughout the day, it is supposed to be done as the painting is being done in your paint booths. So the painting is not done at one shot, where all the paint is dumped. Similarly, the chemical can't be dumped. It is in proportion to the paint that the chemical is being added or should be added to the process. So it has to be an even addition of the paint, a consistent addition of the chemical throughout the day. So very efficient autochemical dosing systems are required for this. So this would be the ideal way to go ahead with the chemical treatment. Yeah, so now you have a small video where what do you mean by thorough and efficient chemical reaction is a small example given. Now first the water in the paint booth. This you can consider as a paint booth where the water is there, where we are adding the coagulants. Then subsequent to the coagulant, this is the actual paint being painted. So the blue paint will be, suppose it's being painted, it will get added to the paint booth water. So what happens is now, the coagulant which is already there in the water, it will start reacting with the paint. Now this will break down the paint into particle form, and it will have a very non-sticky solution being made, a slurry form into the booth itself. Once this slurry form is there, this will ensure that the paint sludge will not stick into the booths. It will start flowing out towards the sludge pit or whatever system you have. So this is the first achievement of the coagulant, that it breaks down the paint, it makes it non-sticky, and then subsequently it can be treated with what we call as a flocculant. So there are two basic components for chemical treatment. Once you add the flocculant to it, what happens is this slurry form, all the solids will start floating. That's why it's called a flocculant. This is finally the end result of a very efficient chemical reaction. This is what you should expect in your booths to happen. Once this happens, you will have this clear separation of the sludge floating on top of the water, and clean water which you can reuse, and the sludge can be removed. Okay, so for proper chemical treatment, as I said, these are the various things that are required, which I mentioned. For auto-dosing system, proper type of chemicals are required. You also have to have proper mixers which can mix. We have mixers which can mix in the booth itself if there are no slush pits, or if there are slush pits, there are mixers available to have the reaction properly and thoroughly done in the sludge pit itself. So these are the various equipment available for achieving that final, thorough, efficient chemical reaction of the paint sludge. Now, how to clean paint overspray sludge? Now, there are various aspects to paint sludge removal in a paint booth, in a paint shop. We'll go one by one. So one is to have a proper system, what we call as an automatic sludge removal system. This sludge removal system can help in ways to remove the sludge completely from the paint booths as well as the sludge pits. Now the second point is, fine, you have an excellent sludge removal system, but at the same time, if the paint booths or the sludge pits are not designed in the proper way, if the paint shop, when it is installed, is it really going to be sludge removal friendly? This is one thing which is very important when you are looking at a new paint shop or your existing paint shop. Is your paint shop really sludge removal friendly? That is a word which I have coined, sludge removal friendly. It means, are the booths properly designed? Now here you can see on the screen there is a booth which is normally called a front water channel design booth. Now what happens is all the sludge will come and get accumulated in the front channel itself. So it becomes very easy because all the sludge is now accumulated in the front of the booth, and it becomes so easy for any equipment to remove it. Similarly for slush pits, you'll have slush pits which are very compact and which can collect the sludge at one point itself, so that these systems can be connected to a slush pit, and the efficiency of sludge removal becomes very high. So such aspects of paint shop being sludge removal friendly has to be considered when you're looking at paint sludge removal. These are the various automatic paint sludge removal system models which are available in the market. These are like you start the switch in the morning, you switch it off in the evening. The entire sludge removal is done by these automatic systems. They take care of the auto dosing of chemicals, they take care of the mixing, they take care of all the aspects of sludge removal which we have just mentioned, chemical as well as the mechanical part. How do these systems work? I will just put a schematic here where I can explain these things to you. Basically, it's a hydrofloaty design, the latest in technology which is now available in the market. These systems are basically where the sludge is pumped into these systems. Along with that, auto-dosing chemical systems are also there. So the coagulant and the flocculant, which I just explained on the video, this entire process and the parameters required to be adhered to are taken care by the equipment itself. It has a PLC control which will it will have only that much of dosing of chemical of the coagulant and the flocculant throughout the day, not at one shot. So depending on what is the paint being sprayed, the settings are there, the models are selected, and subsequently you will have very dry sludge falling in the bin, which can be then taken out. So this requires no manual intervention. It can be connected, as I said, to the sludge pit as well as the paint booths. Now, I just mentioned it can be connected to sludge pits as well as paint booths. How? There are two schematics here. The first one shows how it can be connected to booths, either a single booth or a multiple booth. So you have one automatic system, hydrofloaty system, which can be directly connected to a single booth. Or if you have more booths, like 2 booths, 3 booths, 4 booths, a single automatic system can be connected to these 3 or 4 booths and the job can be done. Now, one of the things which would have noticed is that these systems do not require a sludge pit on their own. If a sludge pit is already available in a paint shop, then fine, these systems can be connected to a sludge pit. But the biggest advantage of these state-of-art systems which have come in now is that they don't need sludge pits on their own, which means you can save a lot on the civil cost, the space, open sludge pits, the pollution. Nowadays in Europe, open sludge pits are banned. You cannot have open sludge pit because of the pollution problems, it's very unsafe. So these are the systems now which are coming in and already entered India and installed at various locations where you see that there is no sludge pit. It is directly connected to the paint booths. But in case your paint booths, your paint shop has a sludge pit, this system can also be used to clean the sludge pits, the existing sludge pits. And there will be some advantages of that where you can use these systems to reduce the quantity of water that is normally there. Because in India, if you see, the sludge pits are like swimming pools sometimes, very large, Now these systems require very compact sludge pits or no sludge pits at all. So there's a lot of saving on the water also, on the space also. These are some of the major advantages of the hydrofloaty system. It's basically, if you see, it's a zero liquid discharge system. One of the major advantages. What does it mean? It means that there is no water coming out of it. All the water is recycled back to the sludge pit or back to the booths. It means, in simple terms, it means there is no load on the ETP because of the paint booths now. Because most of the cases you will see all the water going to the ETP. Since this is a ZLD system, it means that the water goes back to the system, back to the booths, back to the sludge pit. And there is no need of wasting that water and sending it to the ETP because this cleans very efficiently. And you will have this major advantage where it reduces load on your existing ETP also if you have an ETP. So it reduces pollution, it reduces water, sludge pits may not be required. If they are there, it can be connected to sludge pits also. As I mentioned about the sludge pits, very compact, very easy sludge pits. If at all you have downdrop booths, you want to connect to a sludge pit, you have very compact sludge pits. There are no walls in between, very simple design. And you get the sludge out very efficiently. We have shown and proved in the installations done that only 2% of the solids return back with the clean water. 98% are removed with the help of these systems. Similarly, I explained about the concept of front water channel booth. This is a schematic of that it is a side drop booth, but instead of having a large tank at the bottom where all the sludge spreads, which is normally what is seen in the industry, the sludge is directed to a very small front channel of water where it becomes so easy for the automatic system to remove. So you have basically the sludge coming to a very small area with a very small volume of water, and it can be removed very easily, and you have very clean booths, very efficiently the sludge is being removed. So these sort of things, these advantages are there. This becomes a part of the sludge removal friendly paint shop, which I was talking about earlier. Now, coming to the second point after the paint overspray is, I was talking about earlier, a point about the dirty solvents. Now, this again is an area where sludge is being generated. Now, in this case, you have a lot of sludge through dirty solvents. The dirty solvents, I said, the major reason for dirty solvents is either they're used for cleaning the guns or cleaning of the equipment. So you have a lot of the solvents accumulated, collected at the end of the day. You don't know what to do. If you start disposing it, you will have to pay for it. If you start, most of the cases, the painters will throw it in the paint booth itself. It becomes very easy when they clean the guns. But it has two main problems. If you throw in the booth water, which goes to the sludge pit or remains in the water, in the paint booth, it is very dangerous because the solvents will be at the top of the water. They are floating on it. There is a small spark, it is highly unsafe. There are a lot of accidents because of this, because the solvent remains on the top of the water. So very unsafe to just flush the guns inside the paint booths. The second problem is that if you add solvents, which is very important, I repeat again, if you add solvents to the water over there in the paint booth, the subsequent paint sludge removal systems where the chemical reaction and the chemical treatment is there, those chemicals you will need more because you are in a way diluting the action of those chemicals by adding solvent to the water. So you lose out on both ends. You are putting the solvent inside the water and then wasting the solvent. You're also inviting more use of the chemicals and cost of the chemicals. So these two are very, these two should be avoided. Instead of that, what we suggest is that there are a lot of solvent recovery systems now available. The process of this is basically distillation. So you get 100% clean solvents after the distillation, as good as the quality of the new solvent, which you can reuse again for cleaning and other things. So this becomes a very advantageous equipment for cleaning of the dirty solvent sludge. Okay, the next point of this was the grating. I'm trying to hurry through all this because the subjects are very big. And in 45 minutes, whatever time given, I'm just touching on these equipments. So the other area is, of course, how do you clean the gratings and skids? Now, this becomes a very important aspect of the paint shop because normally gratings are sent outside and they are burnt off. Even the hooks and jigs are burnt off, and you will have very warping in them and things like that. So now, to avoid all this and for a safer operation, a hydroblast system is available. A hydroblast system, what it does, it has, as you see at the bottom of this, there are manual held hydroblast systems available, just like a vacuum cleaner, but this will blast with high water pressure. And this will blast and remove all the sludge which is sticking onto the gratings. The second thing is that you have guns which can be used to clean the gratings. There are automatic systems also available. Like recently we have installed 3 systems at Maruti where it's an automatic system where it goes and high pressure systems are cleaning the gratings which are on a conveyorized system, and the entire sludge which falls off we are removing, and again the clean water is rerouted. So that's it, because the production, the grating are on a higher scale, on number of gratings. So manual as well as automatic systems are available for removing of sludge from the gratings and skids, because skids also need to be cleaned regularly. At the bottom of this, I have just given a small schematic. This is exactly what we have done at Maruti. So you will see that from the blasting area, the water along with the sludge slurry is coming to a pit. In the pit, there is a vertical conveyor which removes the lumps and the hard part of the grating sludge which has come into the water now. Subsequent to the vertical conveyor, there are still some fines in the water remaining, because all the sludge will not be removed by the vertical conveyor. So the second part is that there is a hydrofilter provided over there. What the hydrofilter does the fines it removes through filtration, and clean water finally is given out, which can be recycled back to the system. So 100% recovery of good water, clean water is possible through this. How to clean hooks, jigs? Again, another issue of which requires cleaning for the sludge. Now, in this case, there are two options. Well, the first option is chemical cleaning. It can be automatic or batch type. There are special green type chemicals now available in the market. And you can have a conveyorized plant or a batch type plant as shown over here. The one on the top is a batch type plant. The one on the bottom is a ultrasonic cleaning automatic plant. So these types of baths are available with the green chemicals nowadays, which are used to remove and clean the sludge from the jigs, from the hooks, which is a very important system. The second way of doing it is having a fluidized bed or a burn-off oven. Now this also systems are available. I believe one is available installed at Chennai and Pune and various places. Some companies have inbuilt in-house these fluidized beds also. So these are used for cleaning of the jigs, the hooks, very efficiently. These are not burnt actually. This is a pyrolysis process where it is used so that you don't have any bending of the gratings or jigs or hooks inside. So very controlled burn-off ovens are available. So these take care of the cleaning of these jigs, hooks and other things. Now we come to the last part, which is the pre-treatment sludge. We have completed the paint shop part where paint booth part where what all is happening. Now we come to the pre-treatment part. In the pre-treatment, I had mentioned earlier that there is a phosphate sludge predominantly and degrease sludge. We talk about the first one, which is a phosphate sludge. Now conventionally phosphate sludge has been removed by filter press. That is, I think, the most installed equipment till now. The major problem of the filter press is that it requires a lot of time for cleaning. Those who are in the maintenance, and I must have experienced this, that it requires a lot of efforts to clean and maintain this filter press when you remove it. I have seen in installations in Mahindra and all, they require 3-4 hours for cleaning of filter presses, huge filter press. Now this relatively is a very easy equipment, the SS centrifuge separator. What a centrifuge separator is, I'm quite aware, I'm sure you're aware of it, is that it separates the solids and the liquids by the means of centrifugal force. There is no filter media, there is no filter inside that, paper filter or whatever cloth filter. This is just separation because of the high spinning and the centrifugal force created inside a separator. So you have the solid sludge being separated in the centrifuge and the clean solution recycled back to the phosphate tank. So this is an online cleaning. There are no clarifiers required, there are no filter presses required, special nitric cleaning systems and so on and so forth, which normally the conventional equipment requires. But this is a very, the size of this may be 1 meter by 1 meter. It can be kept next to the phosphate tank or wherever nearest. And very, very, very easy for this. It can clean up to about 2 to 3 micron particles of the phosphate sludge. So you have very clean solution coming or going back to the phosphate tank. So this is one of the major equipment change now seeing in the paint shop, where the phosphate sludge is being removed by centrifuge separators. Criteria for sludge removal I just want to touch upon. As I mentioned that the paint shop has to be paint sludge removal friendly. Now this also is very important for the treatment plant, where if I've seen paint shops where the phosphate tank is not heated indirectly but directly. Now, any portion of the solution, if you comes in contact with more than the specified temperature of the bath, like if you directly heat it with electrical heaters or thermic fluid heating or whatever, it is going to have major problems because the sludge rate will increase drastically. So you have to have indirect heating, tank-in-tank heating or a heat exchanger, so to ensure that there is no direct heating of the phosphate solution. So on and so forth, there are a lot of other suggestions for the phosphating. It has to be sloping, it has to see that all the sludge can move out of it, can be collected at one point, so on and so forth. So this makes it a sludge removal friendly pre-treatment system also, to ensure that your tanks are also designed in such a way that it becomes easy for any equipment to be connected and operated accordingly. So this as far as phosphate sludge is concerned. This you can see is the schematic, how it is connected. So this is a continuous system where it is taken out from a conical bottom, going to the centrifuge and coming back to the tank. This is a continuous process, so you will have no rejections because of phosphate sludge sitting onto the components, which is a normal rejection problem for the components, that a lot of phosphate sludge, which is still there in the tank, keeps on sitting on the components, and there's a lot of rejection. So this is a continuous thing. So the percentage of solids inside the tank is monitored properly and removed continuously. These are the advantages of the sludge against your filter press or other systems. So very easy, and it's a very simple design. It's very and suited for this type of application. We have given the systems to many other applications like ceramic cleaning. We are going to Sandvik, we are going to Seco for their some chemical powder, aluminum hydroxide powder removal. So very efficient, and there is no headaches. It's very simple equipment, I think. So this is the last segment after the phosphate, how to clean degrease sludge. Now, normally the skimming process has been adopted throughout, or there are other heating processes where the oil is taken, the solution is taken into a different tank, heated and overflow, such like systems. Nowadays, these oil separators are available. These oil separators can be directly connected to the oil tank. And a pump is there to remove to send the solution to this oil separators. The oil is removed and skimmed off and taken out, whereas the clean solution goes back to the degrease tank. So this again, just like a phosphate cleaning, this is directly which can be connected to the degrease tank. Very compact systems which can connect and ensure the results required, because this can remove to a very high efficiency the oil, the grease inside the degrease tanks. So these systems, either one or in combination, depending on the tank size, volume of the degrease tank, are being used for various paint shops in the industry, and designed accordingly to the various requirements. What type of oil is there, how much is the oil, contamination. So accordingly the process can be added in this. So, so the oil separators, just like phosphate sludge separators, is an ideal solution for removing of the sludge from the treatment section. So I believe this is the end portion of the pre-treatment. I've just added one slide. I think I am still in the time zone. So I'll just mention this, because this is an area where people keep asking us, and we have the equipment and we have supplied this to many places now, that after removal of the sludge, with all these equipment, there is still remains a question: how do you dry it? Because you are supposed to dispose of the sludge. And paint sludge disposal to the government authorities, to whoever, or giving to cement plants or wherever, depending on where your plant is. This requires drying of the sludge. And if you give wet sludge, it is a pain, because then you are charged more for the disposal, or it will not be accepted by people, the cement industry, or for their burning. So this is a special equipment which is launched, called a hydrofilter, where all the sludge which is coming out of a hydrofloaty system or systems installed for removal of the paint sludge can directly feed into this. And the excess water is removed and you get dry sludge. So this I thought would be helpful to all the people here. Just an additional thing is how to dry the paint sludge. So very efficient. Once you have, especially those paint shops where the sludge is very high in quantity, this reduces the volume of the sludge because the paint has a lot of water in it, 60-70% by the time you remove conventionally. In a hydrofloat it will be 20%, 30%, but still this is very effective. Yeah, I come to the end. Any questions? Let me know. No questions? You understood everything? Great. I'm happy. Anything about paint sludge removal or phosphate sludge removal? Any questions about this?
Hello.
Yeah.
So, question from my side.
Yeah.
So, you have told
burn-off
oven install.
Can you raise your hand? Where are you? Ah, yeah. There. Okay, sorry.
You have told burn-off oven you are installed in Chennai.
Yeah.
Do you have any information, any burn-off oven installed in Bangalore?
I am not aware. Chennai I am aware because they have a stall right on the top here.
Yeah,
here only, on this floor only they have a stall.
Yeah, because for us is
yes.
Cleaning that fence is very difficult and even government authorities not allowed to burn.
Yes.
That's why I'm asking.
In Bangalore, I'll need to check. You can check with them. They have a stall here also, the fluidized bed people.
Okay.
So if they have any installation, because they are doing a lot of work here for the because you can have your own, but you know, this installation at a factory. But now what people are preferring it to give it outside and get those cleaned. So they supply.
Having one is again the biggest question for the pollution board. They are not already we are in the red category. Then they will not allow to.
So you will have to give it outside where it is allowed. So there are. I'm aware of installations in Pune and Chennai because a lot of auto industries are there. Bangalore, I will check and let you know.
Sure, sir. Thank you.
Leave your details. I'll give it to you.
Yeah, thank you.
Hello.
Yeah.
I am Pratap Rao from Pune, Phoenix Mechano India Limited. Okay. We have already started your trial 1 to 2 times. We have taken trial also with your representative Punlik.
You are from? Sorry, I didn't hear.
Pune. Phoenix Mechano India Limited.
Phoenix.
Yes.
Okay.
Your representative Punlik visited to us. We have started trial, but it is not complete yet.
Okay.
So today I have understand your whole scenario.
Okay.
So after that we will complete the trial and complete it.
Very nice. Very nice to hear that. Thanks a lot.
Thank
Thanks
you.
a lot.
Yes.
So myself Sachin from Berger Paints. There was one slide where you showed that in the phosphate tanks, there is some correlation with the temperature. Can you throw some light on that? I couldn't get it clearer.
What I mentioned about the phosphating is that zinc phosphate, or iron phosphate, or manganese phosphate, whatever, they each have specified, the supplier of the chemical mention a temperature, heating temperature, say 60 degrees centigrade. Now, how do you heat? That was the point. How do you heat this? You have to get the tank heated to 60 temperature. Now, the easiest way is to put an electric heater or a thermic fluid heater or whatever, you know, inside and heat it, just like you heat your water, you know, inside at home. But now what happens is when you put an electrical heater inside a phosphate tank, the skin temperature of that electrical heater is very high. Yeah, 700, 800, 500. So, though it will slowly heat this tank to 60 degrees centigrade, but in the meantime, the solution has come in touch with a surface which is much high in temperature. Now that is going to create a big problem because that immediately shoots up the phosphate sludge generation rate, right? You will immediately see at the end of it that hard sludge is sticking onto the electrical heater because that has produced so much of sludge near it because of that high temperature that immediately it will generate and all that sludge gets accumulated on the generator itself. Now to avoid that, what is easily done is that the tank, that tank is again jacketed with a water tank or a thermic fluid tank where that outside water is heated or the oil is heated, and that heats up, because then that will be maintained at maybe 70 degrees or 80 degrees, and that will heat up 16. So that will maintain the sludge generation rate within the norms. Otherwise, it will be huge. I have 2 minutes. Any questions, or I end the session? Madam, I am well in time. Okay, thanks a lot. Thank you.
Now I would like to invite Mr. Nitin Vaidya.